This lesson is about radicals. You have probably seen uh, terms like the square root of 10 or the square root of 25, but maybe you haven't used the word radical before. So a radical represents the principal or positive square root of a number. So let me just explain, why are we even learning about this? So sometimes in math, maybe you have seen somebody write something like the square root of 12. And up until now, it's been okay for you to use your calculator, and maybe you've seen a teacher do something like that to say that the square root of 12 is approximately equal to 3.464101615. There's a zero there, and it goes on and on. So this is usually what we would do is we would say that's probably equal to 3.46. That is an approximate answer. And as you get into higher levels of math, approximate answers aren't always what is accepted. So perhaps somebody else would see the square root of 12, and maybe they would see that 12 is the same thing as 4 times 3. And oh, wait, the square root of 4 is 2, so I could write this as 2 root 3 and break that down into this mixed radical, it's called. If you type that in, 2 times the square root of 3, I'm pretty sure you're going to get this on your calculator. It's the same thing, but this is called an exact answer. That's why we would even try and teach you about this. That's why we're learning about this right now. It's just using simplifying radicals is a really important step if you want to leave your answers as exact answers, which we're going to see come up over and over again throughout our course. So there are a few rules. So most radicals are irrational numbers, and we cannot determine exact values for them. We can combine them as we do algebraic terms, so some rules apply. For example, if we see the square root of a times the square root of b, we can say that that is the same thing as the square root of a times b. Okay, so let's see, the square root of 2 times the square root of 3 is the same thing as root 6. This one down here, if we have a radical in the numerator and one in the denominator, we can change that to have a radical of a fraction. We can also use those principles where the b's would cancel each other out, and that's the same thing as just root a. So there are some different strategies that we can use to simplify these radicals. One thing that you need to know, radicals such as 2 root 3 and 5 root 3 are called like radicals, just like terms when you learned about that before, like 2x plus 5x. So only like radicals can be added or subtracted. Radicals such as root 2, root 3, root 12, and root 18 are called entire radicals. But if we break them down into mixed radicals, for example, 2 root 3 is a mixed radical, 3 root 2 is a mixed radical, and 5 root 7 is a mixed radical. Expressed as an entire radical. So this is kind of like going backwards. If both of these were radicals, we must have had something like the square root of 25 times the square root of 2. So that's really the same thing as root 50. But it's kind of like with fractions, when we always want to write something in lowest terms. Normally, we wouldn't be very happy with an answer like root 50. This is what we are going for. We would almost always want you to change your answer to a mixed radical and simplify it if you can. So this one, maybe you see 4 times 4 is 16. So that's the same thing as root 16 times root 5, because the square root of 16 is 4. So if I multiply those together, I get the square root of 80. That is the entire radical, but we are much happier with the mixed radical than we are usually leaving our answer as an entire radical. Example 2. This is more what I would expect you to see. You have the square root of 48. Well, I know that I can break that down. 48 is the same thing as 16 times 3. I'm going for as big of a number as I can there. 16 times 3, the square root of 16 is 4, and I still have a root 3. I don't want to break down that root 3 and get any decimals. I'm trying to go for exact answers. So once you break it down like that, you're done. One thing, imagine that you didn't remember that 48 is the same thing as 16 times 3. I've also done it this way myself. If I don't have a calculator on me and I'm not quite sure, what would I think of? 48, to me, 48 is always 6 times 8, right? So that's the same thing as 6 times 8. 6 times 8 is 48. I know that. What can I do then? I can break down, what would I do? I would break down the square root of 6 as 2 times 3, and I would break down 8 as 4 times 2, and I'm trying to go into lowest terms here. I notice that I have the square root of 2 times the square root of 2, and that's the square root of 4, times the square root of 3, times the square root of 4. That's the square root of 16, times the square root of 3, which is really 4 root 3. I don't think that's any easier. You're really looking for the largest multiple here, 16, and we're looking for a perfect square, because then we can break it down further. So I'm basically looking at something like the square root of 27, and I'm thinking, does that have any perfect squares in it? Perfect squares like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 7 times 7 is 49, 64. This is the kind of thing that we're looking for. So 27, I know, is 9 times 3. And so I know that I can find the square root of 9 exactly, which is 3. So my answer would be 3 root 3. Example 3, what do we have here? So we see a large number like 24. And I'm trying to break that down as much as I can. So maybe right now I know that 4 times 6 is 24. So maybe I would write 24 as the square root of 4 times the square root of 6. And then I have 5 root 6 over here on the right. Okay, what does that achieve? So 4 times 6 is 24, but I can find the square root of 4. So I would have 2 times root 6 times 5 root 6. Let's see what we get. So now 2 times 2 is 4 root 6 times 5 root 6. What we can do with this multiplication is we can multiply our coefficients here out front. 4 times 5 is 20, and 6 times 6 is 36. So I end up with 20 times 6, because the square root of 36 is 6. So I end up with 120. You notice I wasn't ever trying to find the square root of 6. I wasn't rounding off my answers as I went. I'm trying to work with exact numbers, and it ended up giving me a pretty nice answer at the end. So I guess my advice would be try and break down anything you see. Like I noticed the square root of 8 is the same thing as the square root of 4 times the square root of 2. And then I have 3 root 6, and then I have 7 root 3, which I can't break down at all. Right now, I see this would be 4 times 2, though, root 2, because times 3 root 6 times 7 root 3. What else? That would be 8 root 2 times 3 root 6 times 7 root 3. Okay, something else I could do is I could multiply my radicals together. 2 times 6 is 12, times 3 is 36. I can also multiply my coefficients. I can multiply 8 times 3 times 7. So I get 168 times the square root of 36. So I took my radicals and multiplied them separately, and I took my coefficient numbers out front here, 8 times 3 times 7, and I got 168. But that's 168 times 6. So I get 1008 as my answer. Exact answer, no rounding throughout. I'm just trying to simplify and do the best I can to get a final answer. Some other rules that you might notice here in example 4, these are like terms. So I've got a root 7, a root 7, and a root 7. So the question is, how many of those root 7s do I have? I have 5 of those root 7s, plus 4 of those root 7s, take away 3 of those. So that I end up with 6 root 7. I have collected my like terms just like this was 5x plus 4x minus 3x. I can't break down 7 any further, so that one is done. Over here, maybe you noticed I have a root 5 and another one there. So I have 7 root 5s because I'm adding my coefficients together. And then I have a root 13 here and here. 7 minus 2 is 5. So I have 5 of those root 13s. When I look at that, I can't break down the square root of 5 any further. I can't break down the square root of 13. I can't multiply those together because this is an addition question. So it's like, are these like terms? No. Can you add them together then? No. So you have to know in some cases that would be your final answer. Down here, oh my goodness, like I hope things like this pop out at you. Oh, root 45 and root 20, I can break those down. So I want to write this in a more simplified form. 45 I know is 9 times 5. And 20 is the same thing as 4 times 5. So by doing that, I'm looking for these perfect squares, 9 and 4. I can actually take the square root of 9, which is 3. And I can take the square root of 4, which is 2. Some students do that. Once you actually take the square root of 9 and you get 3, the radical sign disappears, right? You found the square root of 9 and now you have 3. So then how many root 5s do you have? You have 1 plus 3, that's 4. Take away 2. So you're left with 2 root 5, and the square root of 5 can't be broken down any further. So we have a simplified answer, and it's an exact answer right there. This one, just so you know, when you have a radical sign with 2 terms underneath, they can also be split up. So I could write that as root 4 times root a, which is a rule that we saw on the front page. And this could be written as 5 times root 9 times root a. A has to be greater than 0 because we're not finding square roots of any negative numbers right now. So what do I see here? I see that's just 2 root a. So again, I found the square root of 4, so the radical sign disappears because the square root of 4 is 2. And then what do I have over here? I have plus 5 times 3 root a, because I found the square root of 9 and that's 3. So I have 2 root a plus 15 root a, and that's a like terms question now. If I have 2 of those root a's and I add 15 more, I have 17 root a. So this lesson, this could be all brand new to you. It's good to look over the rules on the front page. It's really good to practice the homework questions, because this is a skill that we sort of don't spend a lot of time on, but hopefully you'll notice things like, rules like you'd never leave a radical like the square root of 24, because you can definitely break that down further. We're always trying to go for an exact answer in the simplest form possible.